Okay, I wanted to post some hints for this chemistry lab this week. This is going to cover everything that we've studied in chapter 4. So the first one, you're talking about making pancakes, and it says what is the ratio of mix to water. Now the order of the words is really important. Remember, ratio can be written two ways. So you can do mix to water, okay? So you can use a colon, or you can use a fraction. So mix over water. Those are two ways to represent a ratio, and the order matters. Mix comes first, water comes second. Number 2, you want to make 10 pancakes. How much mix do you need? So we know how much mix is required for, let's say, 7 pancakes or 14 pancakes or 21. How much mix is required for 10? So if 7 pancakes use 2 cups of mix, the question is, how many pancakes, or 10 pancakes, would use how many cups of milk? So there's a proportion. And there are multiple ways you could set that up. You don't have to set it up the same way that I just did. The same thing for the sugar cookies. How much flour do you need to make 12 cookies? So that's another ratio. Let's move this over a little bit and look at number 4. The resistance, okay, here's where we get to the chemistry information. The resistance of a solution of copper sulfate is measured at 0.51 ohms when 2 electrodes are 4 centimeters apart. Okay, I have no idea what that is talking about. I took chemistry very, very long ago. I don't know what they're talking about, but that does not mean that I cannot get the problem correct. So let's keep going. If the resistance is directly proportional to the distance between the electrodes, what is the distance between the electrodes and the resistance? Okay, again, I don't know what they're talking about, but I can follow directions. So they're talking about two things here. They're talking about resistance and distance. So I'm going to set up a proportion with resistance over distance equals resistance over distance. So we know the first resistance is 0.51 ohms, and that distance would be 4 centimeters. Continue reading. The next resistance is 8 ohms, and we're trying to determine the distance. So that's just a proportion. Again, I don't know what they're talking about, but I can figure out the proportion based on just the language. Rust is an iron oxide formed when iron reacts with oxygen present in the air. If this compound is in a 3:2 ratio of oxygen to iron. Now listen, 3 comes first and oxygen comes first. 2 comes second and iron comes second. So you've got 3 oxygen atoms for every 2 iron atoms. So again, you're going to set up a proportion. You've got oxygen on the top, you've got iron on the bottom. So there's another proportion. I think I'm going to skip number 6 because it's just like what I just said. Again, make sure you read it. Carbon is first, so it goes with that first number. And hydrogen is second, so it goes with that second number. Number 7. Now this one is different. Number 7 is different. I love this problem. It says, it's talking about rust, iron oxide, compound, 3:2 ratio, whatever. Okay, 3 is the ratio of oxygen atoms, and 2 is the number of iron atoms. Now watch this. So 3 is your oxygen, 2 is your iron. Okay, 3 oxygen, 2 iron. But let's keep reading. It says if 72,000 total atoms. Now that's important. These are total atoms. We're not told if those are oxygen or iron. So what we have to do is we have to compare this total to this total. Well, that's pretty easy to do. If there are 3 oxygen and 2 iron, there are 5 total atoms. So we've got a total number here, 7,200, and we have a total number here, which is 5. Number 8, compound bromine trifluoride. I'm probably pronouncing that wrong. Bromine comes first, fluorine comes second. Again, this one is talking about the total number of atoms. This is the total number of atoms in the compound. And so what you need to do is you need to compare that to the total number of atoms here. The total number of atoms here is not 1. It's also not 3. 7 and 8 are very similar. Okay, for 9 and 10, you're going to use our formula. You can either use is over of equals percent over 100, or you can use part over whole equals the percent over 100. So that formula is going to work for these two problems right here, 9 and 10. It's actually going to work for 11 as well. The only difference is you're asked what is left after it's being decreased. So you need to get your answer, and then you need to subtract that. Decrease means to subtract. So you started with 180.2 grams. You're going to figure out what 25% of that number is, and then you're going to subtract that from the total. Let's move to the last page, and let's see if I can get my screen to go with me. Number 12, you are increasing. So again, on number 12, you're going to use those same formulas, but this time you're going to get 33% of 220, and then you're going to add because you're increasing for that particular problem. Number 13, you've got a Chemistry 2 class with 90 students, 26 are freshmen, 35 are sophomores, and the rest are juniors. What percentage of students are sophomores? So again, you're going to use, I would use part over whole equals the percent over the 100. Now you have to determine, what goes in that particular area. Ratio, I want you to write your ratio as a colon if you can for this particular thing. So you're going to have freshmen to juniors and write it as a colon. Number 14, 19, how many vehicles were produced? Okay. An automotive company produces cars and trucks. If 19.5% of the production of vehicles is cars, so this is cars, and there were 208,122 cars, so this is also cars, how many vehicles were produced that year? Now, notice vehicles is your total number. So in other words, cars and trucks. We know the number of cars, and so I don't want to say too much. I would use part over whole equals the percent over 100. Now, is this the whole or is this the part? Again, they're producing cars and trucks, and we're talking about how many vehicles total. So I would guess that the cars is the part of it, and what we're looking for is the whole. This is what we're trying to figure out. Number 15, it's another long one. What percent of copper sulfate is copper? That's part over whole. Again, part over whole equals percent over 100. Number 16, what percent remaining is copper? Okay, all you have to do is you have to subtract from 100%. So you have to have 100% of total ingredients, and you've already been given these three, so you're just trying to figure out what part is copper. Number 17, RCC had a total of students that had 24 enrolled in chemistry. What percentage of them decreased? Okay, so remember here, you put the amount changed, this is the percent change problem, over the original, and then you're going to multiply that by 100. These two problems right here, these two, are percent increase or percent decrease, okay? I have a video of that, but this is the formula. You put the amount that it changed over the original. So you have to read the problem, and this is a pretty straightforward one because I've given you dates. The original date was 2015. And so you're going to do the same thing for 17 and 18. Again, those are percent increase and decrease problems, and I've added an extra video in my resources link this week if you need some practice with that. So those are some hints for the chemistry lab, and I hope that'll get you started. Don't forget, you have to show your work on the lab. So you can either type the work or you can write the work and upload it to your Word or PDF file. But you must show the work for all 18 problems. There are 18 problems on the lab. I expect to see how you set up all 18. Okay, thanks.